Okay, last section of chapter 1. So we are going to describe pairs of angles here. Okay, so we're going to talk about complementary and supplementary angles. Okay, complementary angles have a sum of 90 degrees. Okay, and you would say that each angle is a complement, not calling the other one pretty, but instead saying that each one is a complement of the other. Okay, meaning together they add up to be 90 degrees. Okay, supplementary angles then have a sum of 180 degrees. Okay, and each angle is the supplement of the other. Okay, so the way I remember this, okay, if you need help, okay, you can think of a C, and again, not an artist here, and an S. C is like half of an S, right? So C is 90 because that's half of 180. Okay, so if you need to remember it that way, that's kind of what I used to tell myself. Okay, now I've taught it enough that I just know it. All right, so then complementary angles and supplementary angles can be adjacent angles or non-adjacent angles. So when you have adjacent angles, that means that two angles that share a common vertex and side, but have no common interior points, meaning they don't like overlap each other basically. Okay, so you can see here, whenever I talk about adjacent, I talk about next to, okay, or touching, right? Okay, so these share this side, as it points out, and it has this common vertex. So 5 and 6 are adjacent angles. Angle 5 and angle 6 are adjacent to one another. The angle 7 and angle 8 are non-adjacent angles because they don't share anything, okay? Yes, they're kind of next to each other on that paper, I guess you could say, but they aren't touching one another, okay? Got to be touching, but not sharing, okay? All right, in example 1 then, it says, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. Okay, so let me see here. I need, for complementary, I need a pair that matches up to 90. Supplementary, I need a pair that matches up to 180. And adjacent, I need touching, right? All right, well, I can easily see the touching, right? So let's knock that out of the way. Touching are angle BAC. Remember, A has to be in the middle. And angle CAD are adjacent angles. All right, well, let's see if those add up to be 180. Well, actually, I don't even have to use my calculator because I know if they added up to be 180, it would be a straight line, okay? Because remember, a straight angle is 180. So those aren't, but maybe these two are. So let's do 127. They kind of look like they are. Plus 53 is 180, okay? So then I know that angle CAD and angle RST are supplementary because 127 plus 53 equals 180. And you can say here because they share ray AC. Okay, Now I gotta find two that add up to 90. Well, that one's 127, so that one I can't use. So, well, ding ding, it should be the other two, right? Because I don't have a 90 by itself, and that would be true. So angle BAC and angle RST are complementary because 37 plus 53 equals 90 degrees. Add the degrees up to 180. Okay, all right, let's turn the page there. It's telling me on example 2 to find these angle measures. So it says angle 1 is a complement of angle 2, and angle 3 is a supplement of angle 4. Okay, the measure of angle 1 is 62, and the measure of angle 4 is 47. Well, shoot, those are both smaller than 90. Okay, so guess what? You have to know your vocabulary words. You have to know which one is which. And remember, C is half of S. So C is 90, S is 180. Okay, so this one is 90, this one is 180. So 90 minus 62 would leave me with 28 degrees is equal to the measure of angle 2. Okay, on B, I have 180 minus 47, and that would leave me with 133 degrees for the measure of angle 3. And that's that, okay? I can tell you right now, those types of problems will be on your test, so you need to know which one is which, okay? And again, they'll be both smaller than 90, so you have to know the difference between complement and supplement, okay? Example 3 now, when viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Find the measure of angle BCE and the measure of angle ECD. Well, this makes a straight line down here. And I know that straight lines are straight angles, and that is 180, or it just said supplementary, again, 180. Okay, so if I didn't know what supplementary means, there's my answer. And then maybe I could go back on the test and then fix that one if I did it wrong. Okay, so I know that these add up to be 180. So 4x plus 8 plus x plus 2 equals 180. I have 4 x's and another one, so I have 5 x's. 8 and 2 make 10. Subtract 10, I get 5x equals 170. Divide by 5, x equals 34. Okay, now plug it in. X plus 2 would be the easiest one, right? So the measure of angle ECD, 34 plus 2 would be 36 degrees. Then it'd be the easiest probably to take 180 minus 36 to get BCE, which is 144 degrees. Okay. All right, other angle pairs now. Linear pair are adjacent angles whose non-common side are opposite rays. Okay, meaning they make a straight line. Which means that they are supplementary or 180 degrees. Okay, and you can see that here, right? It makes a straight line down here, which I know automatically is 180 degrees. Okay, these are called linear pairs. Together they make a line. You could think of it that way too. Okay, linear pair, line, straight line, 180 degrees. Okay. All right, and then the next one, vertical angles are when two angles when two angle sides, couldn't read my handwriting there, form two pairs of opposite rays. Okay, so let me use some colorful here. So I'm looking at angle 5. Angle 5. Let's do it this way. Well, angle 5 would have to be vertical then to, if I extend that to make an opposite ray, and I extend this to make an opposite ray, that would be vertical to 4. Okay, so 4 and 5 go together. They're kind of like across from each other, right? Okay, same thing here. If I was going 3, extend it, 3 on this side, extend it, it goes to 6. So 3 and 6 are vertical angles. So you can kind of think of across from each other. And just as like a side note, we'll talk about this later and prove it, but vertical angles are congruent. Okay, make sure you know that. Vertical angles are congruent, or that means that they have the same measure. They're equal to each other, okay? All right, turn the page here. Okay, identify all the linear pairs and all the vertical angles in the figure. All right, so linear pairs make a straight line, and pair means it's only 2. So here's a straight line. Well, these would make a linear pair, but oh wait, there's 3 angles there, so that won't work. All right, well down here, there's 2, so angles 4 and angle 5 make a linear pair. See what else? Are there any other straight lines? This doesn't make a straight line. This one does. Okay, well again, I have 3 on the right hand side, so that won't work. And on this side, oh, I do have 2. So angle 1 and angle 4 are a linear pair. Okay, now I want to look and see if I have any vertical angles. So vertical angles, remember, they kind of make an X with each other. They're the same size. Their sides of their angles make opposite rays. So actually, I kind of have it already lined out for you here. You can see here, 1 and 5 would just extend. Okay, so angle 1 and angle 5 are vertical angles. Okay, all right, example 5. 2 angles form a linear pair. All right, well, automatically I know that I have this linear pair, right? And it says the measure of one angle is 5 times the measure of the other angle. Okay, one of the angles is 5 times the measure of the other angle. So I don't know what the other angle is, so we could call that X, right? And I know that the other one is 5 times as that, so 5X. And I know a linear pair makes a line, which is a straight angle, which is 180 degrees. So I know that this is all 180 degrees. So then I could say that 5X plus X equals 180, or 6X equals 180. Divide by 6, X equals 30. So one of the angles, this one here would be 30 degrees, and the other one would be 180 minus 30, which would be 150 degrees. Okay. Oh, you couldn't see any of my work there, sorry. There's that if you need it. All right, so now let's look at this concept summary. So not really anything to write here, but I do need you to pay attention because this is important. It says interpreting a diagram. There are some things you can conclude from a diagram and some things that you cannot. For example, here are some things that you can conclude from the diagram below. Okay, it says all points shown are coplanar, okay, which means that they're on the same plane. Okay, points A, B, and C are collinear, and B is between A and C. So A, B, and C are all on the same line. B is in the middle of A and C on that line. Okay, line AC, ray BD, and ray BE all intersect at point B. Okay, they all share that point B. Angle DBE and BC are adjacent angles. They're touching, right? And angle ABC is a straight angle. ABC is a straight angle because it's a straight line. Point E lies in the interior of angle DBC. DBC is in the middle. Yep, you got it. Okay, now here are some things that you cannot conclude from this diagram here. You cannot say that the length of A to B is congruent, sorry, not the length, I should say the segment AB is not congruent to BC. Okay, there's nothing there indicating that they are the same length. Even though it appears that they may be, I cannot assume that to be true. Okay, you cannot conclude that angle DBE is congruent to angle EBC. Again, even though it looks like BE might be cutting this big angle in half, you can't assume that because there's no markings, okay? I just know that it's in the middle and that's it. Okay, and then lastly, I cannot say, I talked about this once already, I cannot say that ABD is a right angle because nothing is there telling me that that is true, okay? If I wanted to say that those three things that I just went over are true, then this would have to be given to you. So to make such conclusions, the following information must be given. Okay, let me make this darker for you. To be able to say that AB is congruent to BC segment-wise, this hash mark has to be there. To be able to say that angle DBE is congruent to angle EBC, these little arcs have to be here. And in order to be able to say that angle ABD is a right angle, this box has to be in the corner, okay? You have to see those things in order to be able to say that's true. Okay, otherwise do not assume anything to be true.